my issue. What I want to do is talk about what we're going to be doing this semester, and I'm going to introduce the first exercise or activity we'll be doing for this week, which will be mainly a review. And then I want to continue my discussion on relativity that we left off on Tuesday. So I do want to make a plug, and I sent an email to you guys yesterday for this course, Engineering 220. It's a MATLAB course. It teaches you how to solve complex problems with a computer. And most of you folks who are engineers at some point will have to use or will have to learn how to use MATLAB. So this would be a great opportunity for you to take this course. It's a pretty laid back course. If you have the time in your schedule, you might want to consider it. Do you folks have any questions on the lab syllabus?
I have some questions.
Sure, go ahead.
So it was written that we are allowed one late day if lab report is on the exam day. Can you go over that?
Yeah, so let's say I for some reason set up the due date of a lab on a Thursday, and I have an exam on a Thursday. I would rather have you get ready for the exam. So you can turn in the lab on Friday, okay, without being penalized. Okay, but then after that, if you turn it on Saturday, then you lose points. But you will get an extra day to turn in a lab report if the due date falls on the same day as an exam.
Okay.
Okay. Like I said, I'd rather have you focus on getting ready for the exam. That's gonna be worth more than the lab report. Okay. Other questions?
And then,
oh, go ahead.
Yeah. So there it said that you are free to change the format of the report as long as you include an introductory paragraph and other pertinent materials. So, change some section, or if we are changing, it has to be a whole new report.
Well, some people, what they like doing is they write their own report, but then they just show the data and the analysis, but there's no purpose or procedure, right? And that should be in there. So these labs are written up. I mean, same as 205. These labs are written up so that you don't have to do that. You don't have to spend the time to do that. All you have to do is fill in the blanks, fill in the theory section. You might have to do a derivation. You might have to do a conclusion, but you don't have to write the purpose of the lab and the procedure. So if you're going to write your own from scratch, I want to see the purpose and the procedure there. You can summarize it in your own words, but there's no need to do that. But some people like to do that. So that's why I put that statement in there. Because I don't want to get a lab report that just shows the data and the results, and that's it.
Okay. As we are doing lab at home, so will you still assign lab partners?
No, not this semester. It's really hard, especially with COVID. I mean, I don't want to jeopardize your guys' health. So, and I don't want to force that upon you. I'll get in trouble. So yeah, the labs you're doing the labs by yourself this semester, which makes it a little bit harder. There's no reason why you can't communicate with each other, but you're going to be collecting your own data. All right, you can communicate with each other, and we set up we had one person set up a Discord, so if you join the Discord, you can get on it and ask questions, and you guys can help each other, or you can use a discussion board, whatever you want to use. Okay, but yeah, no, we're not going to have lab partners this semester, which makes it a little bit harder.
Okay.
Other questions?
So I ordered my lab kit off the I ordered my lab kit, but when am I gonna be able to pick it up? Am I gonna get an email once it's ready, or?
So I asked about this yesterday. I talked to the Tyler because he's been arranging this. So if you want to pick it up, call them to tell them you want to pick it up. Otherwise, they will mail it to you.
Oh,
Now,
okay.
it won't be available until the 8th of February. Okay? And the reason why is because I got to give the bookstore the lab kits. I'm sorry. I got to give the bookstore the roster. So I'm going to look at the roster on Monday, see who's left, and I'll give them the roster, and then they'll start processing the orders. So it gives them a week to process the orders. And then you can go either pick them up on Monday the 8th, or they can mail it to you. And if it gets mailed to you, you'll get it by the 10th.
Sir?
Okay.
When I was buying the lab kits, like it gave the option of whether I wanted to pick it up or if I wanted it mailed to me, and I just said I wanted to pick it up. I don't have to call if I said that, right?
Just in case I would. I mean, this is what Tyler said. Tyler said you want to contact them. So, just in case, just let them know.
Okay.
So there's no mix-up, right? It's better to be safe than sorry. Okay. I mean, if you can pick it up, I prefer that you pick it up. So next week, we're going to start our first lab, but it's really a prelude to the main lab. Next week, you're going to be building something for me. Okay, you're going to be building something for a lab that we're going to be doing. And some of the stuff is easy to build. I'll talk about it next week. Most of the equipment you can get from home, like paper plates, paper cups, things like that. But you're going to make a video testing your device. So basically, you got to use static electricity. So, the lab kit does have things that allow you to generate static electricity, but you have things at home that you can use to generate static electricity. For example, if you take a piece of fur and rub it on styrofoam, if you have that available at home, you can charge things up. Okay, so if you have that available, you can do that. You can actually test your equipment for your lab at home. But if you don't, you're gonna have to pick up the lab kit, which has the fur and the rubber rod that you need to charge up, etc. Okay. So it depends. I mean, you might need to pick up the equipment as early as you can. Or if you have stuff at home where you can generate static electricity, then use the stuff you have at home. Because I think our first lab, you can pretty much do everything with something you have at home. But if not, if you don't think so, then pick up your lab kit as early as you can. Let them know. Okay. Other questions?
I received an email where it said that my order for the lab kit, like, it is on back order. So, like, does that mean that they are still preparing for it?
Yeah, the lab kits are there. I mean, because Tyler created the lab kits over the break. And so, I mean, we had all the equipment. So they're probably just processing it. I think if it said it's backward, basically what's happening is they're waiting for me to give them the roster. So which I'm going to do on Monday, and then they'll process it, and the kits will be available on the 8th. That's how I arranged it with them. So so you can, if you might have clicked the box that says I'm going to pick it up, I would still contact them, let them know that you're going to come pick it up, just so it's okay. And they also get to know how many people are coming, because we're still doing social distancing in the bookstore. Okay. Yeah, last semester, well, you guys saw what it was like last semester, right? We did it a little bit differently. You guys who took Physics 205 here, you came to the parking lot and picked up your lab equipment, right? In last semester?
I did it when we were on ground.
In the fall?
Like on campus.
Yeah, you came on campus into the parking lot and picked up your lab. In August.
I did
it.
I'm sorry, you're breaking up. Right, and I'm talking about August. Actually, by the way, I just got a message saying my internet connection's unstable, so.
Yeah, you cut off for a little bit for like,
Right.
like 5 seconds or so.
Okay, yeah, my internet connection does get bad at times. Luckily, I'm recording, I'm doing a separate recording, so the separate recording will be fine. So Ralph says, I'm sorry, go ahead and repeat what you had said.
No, I was just saying that when I did 205, we were on campus, like it was not COVID that time.
Oh, you took it the semester before, but yeah, a lot of folks, that's right. A lot of folks took it last semester, and so they came to the parking lot and picked up. If you took 215, same thing. You came to the parking lot to pick up your lab equipment, right?
For 215, he did not make us have the lab equipment. We just filled in the blanks in the lab. We didn't do much. Like he did the experiment and then he shared the video, but we didn't do anything practically.
Oh, okay. Okay. All right.
Like some of the labs were done practically, which were before we went online, but then some of the labs were not done.
Oh, okay. So yeah, I can't. I'm just not remembering. You didn't have. So you took it last spring.
Yeah.
Okay. Okay. Sorry. Yeah. Yeah. The folks who took the physics classes last fall, they had to come onto campus and pick up. They would drive in their car. We'd hand them in the car. They'd be sitting in the car. We'd hand them a kit in their car. So. Okay. I'm hoping that you've read or you will read the materials in the week 1 module. And a lot of it's review stuff. A lot of it's stuff you've seen in Physics 205 where there's a handout on how to handle air propagation and how to handle significant figures, etc. So, and the syllabus is there too. So take a look at the week 1 module and there's documents there that you're going to need to read. And then there's also a document which is your first activity, which you're going to be turning in a week. You should see it in the lower left-hand corner of the screen, which is it's called the get the name right, review worksheet. It's just basically practicing on Sig Figs, air propagation, and answering a few questions. So I'm going to say a little bit about that today. Okay. This activity, since it's part of the lab, is to be typed up. This activity is worth 25 points. Okay. All our lab activities are not equally weighted. Some lab activities are worth 20 points. This one's worth 25. And there's some that are worth 40 points. Okay. They're not equally weighted just because of the amount of time you have to put into them and the amount of work you have to do to write them up. And so there's a few labs, for example, there's a lab on properties of charge, which is kind of long, so I make that worth 40 points. And because it's a video lab, it's actually, to me, it's an easier lab for you guys, okay? There's a couple of labs at the, on analyzing circuits and building circuits that are worth also 40 points. They're longer. But then there's some shorter labs and they're worth 20 points. There's a couple where you have to demonstrate a skill. You're going to have to learn how to use a multimeter and an oscilloscope. And so those labs are worth 20 points. Okay. So let me go over some of, actually, before I go over my expectations of the lab, one more thing. For 5 of the activities this semester, you are not going to be doing a written report. You're going to create a video of the lab that you did. So I'll tell you the ones they are. So there's a lab called Properties of Charge. Actually, you're going to build the equipment for the Properties of Charge lab. Okay, then you're gonna, so that's one video lab. You're gonna build two things, and they're not hard to build, okay? One of them, you just need a paper plate or a pie tin, and you gotta glue a handle to it. You can use a paper cup, all right? So, and then another one, you're gonna build something called an electroscope. And I'll talk about that next week. So you just gotta do, create a video that shows it works. Then there's the properties of charged lab. It's qualitative. There's not any, there is no data analysis. It's basically you observe and explain. And so I'm going to have you build a video or create a video where you show me the effect and then you explain it. Okay. There's one called the Multimeter Quiz. Where you're going to demonstrate to me that you know how to use this multimeter. So there's an exercise I'm going to have you go through, and basically you're just going to go follow the steps in the exercise and video it. Okay. And these videos don't have to be super high quality. I mean, when I did this last semester, some students were really good at creating the videos, some were not. So I would get some videos that were 5 minutes long and they showed everything. And then I would get some videos that were 40 minutes long where they were just, you know, they hadn't prepared for it at all. They just did it on the spot. It demonstrated the results, but it wasn't done very efficiently. The student didn't practice. Okay. I am not grading on the quality of the video. As long as you clearly demonstrate what you need to demonstrate about the lab, that's fine. I can always, if there's a lot of stuff, I can always skip through the video, and I can always run at double speed. So I just want to see that you can explain things or demonstrate that something works. Okay, that's really what I'm looking for. If there's a lot of extra stuff in it, I can just skip through it. That's what's nice about the videos. Okay, so I did have some videos that are 40 minutes long. It took an hour to download. So I'm not going to have you email me the videos. What you're going to do is you're going to upload them to YouTube. So there's another one called the Oscilloscope Quiz. You're going to demonstrate how to use one of these. The oscilloscope, normally they're big devices. We have a special one that's about this big. It's in your lab kit. And it's like 25 bucks. And then the last one is a DC motor lab. You're going to build a motor. You're going to build your own motor with the kit that we provide you. And it's got to run under a certain voltage to get an A, 3 volts or less, if you want to get an A on the project. And so you're gonna create a video showing me that this thing works at a particular voltage. And in all the videos, I got to see your face. I want to see that it was you that's doing the lab. Okay. So you all have phones. Okay, you all have cell phones, and some of you guys have computers with videos. You shouldn't have any problem videotaping things. If you do have issues with videotaping or you need some sort of resource, let us know, because we can connect you to folks on campus who can provide what you need to create the videos. Okay. So those are 5, and then the other ones are all written. There's 5 that are videos and 5 that are written. So the first one is what you see in the left-hand corner of the screen. Okay. So let me just say one more thing. So you want to subscribe to YouTube. You want to create an account on YouTube. And so it's very easy on YouTube. You can just create your video and then just upload it to your channel. You can create your own channel if you want. It's up to you. So when you upload the video, you can make the videos private so that only people who have the link to the video can see it. So if you make it private, send me the link, so otherwise I can't see it. Okay? So it'll be there on YouTube. Nobody else can see it except for the person who has the link. Okay, or you can make them public. Like the videos I'm creating for the class, I'm making them public. Although probably you guys are the only ones who are watching them anyway. So that I don't have to give you a link. Otherwise, if I made them private, I'd have to give you a link every time I create a video, which is a pain. That just saves me the work from emailing you over and over again. Okay. All right. Just to reiterate some things regarding the introductory video that you should have watched on Canvas. Okay. Every lab report that's written this semester has to be typed up. Every aspect of the lab report has to be typed up, with the possible exceptions of any figures you have to draw. That part I'll let go. Although some folks are good at drawing figures on the computer. And if you've had engineering 22A and 22B, you're probably going to be pretty good at drawing figures on the computer. Question is, are the labs pretty much the same as 205 labs? Pretty much in terms of writing them up, yeah. Same expectations. I mean, I might be a little bit picky I might be more picky when it comes to Sig Figs and things like that. Okay. So everything will be typed up. Okay. Points will be deducted for anything that's handwritten. Of course, this is all spelled out in the syllabus, so I want you to go through the syllabus. Late labs will be penalized 15%. It's 15% per day all the way up until the end of the semester. If you turn something in at the end of the semester that was due 14 weeks earlier, you're going to get negative points on the lab. Okay. Graphs. So the graphs we'll be doing will be done with graphing software. And it is important that the graphing software will give you the curve fit parameters and the uncertainty. Okay? It will give the curve fit parameters and the uncertainty. Because some people will go to because you guys mostly use graphical analysis, correct? Some people might use something called Davis. There's a lot of free stuff on the internet, but as long as the software if A, B, and C are the curve fitting parameters for your data, as long as the software gives you this, then that software is fine. Because if I don't see these numbers, if I don't see the uncertainties from your curve fit, you'll lose points. Okay? So there's the new some people will actually go to the graphical analysis website, download their new version. Their new version doesn't show these values. Okay. But the old version, if you had, for example, Physics A with me several semesters ago, and you had the old version of graphical analysis, it does it. And then some of you guys who had Physics A with me, I introduced you to Davis, which is free software. That software will also do these kind of curve fits, where it gives you the uncertainty and the curve fit value. This one's a little bit fancier software, but it works fine. Okay. And if anybody tries this and they're having trouble, I will help you. Because I know that some students in some of the other classes last semester had some issues. But I haven't. I don't know. I'm not sure. I'm not sure what happened. Regarding the labs, I don't drop lab scores. There's no lab scores that I drop. And like I said before, in your videos, I need to see you in the lab, in the video, when you're doing the lab. If you make up data for a lab, I will give you a 0 on it. Okay? Or if you give me a lab report from a previous semester, I will give you 0 on it. I change the parameters every semester, so that's going to be easy for me to catch if you're using data from a previous semester. Okay, because the lab kits have different. I changed things in the lab kit this semester, so it's going to be hard to give me stuff from the previous semester. Okay. Just real quick, I kind of wanted to just show you the Canvas page for the lab real quick. So just give me 1 second. So here's the Canvas page, and I'm going to go to modules. And we can do the same thing with the main course, but so this is the week 1 stuff, and so I have the syllabus here, the Sig Fig handouts. This is something from I'm pretty sure from Aviva's class, if you had Aviva for 205. And I have lab report reminders. These are my pet peeves for lab reports. Okay, so these are things I will take points off in a lab report. So you should read this, okay? And I will remind you of some of them as we go through the semester. But I expect you to read this. And so all our modules are here. So here you have the documents to read, assignments, and videos you may need to watch. So like for example, for week 2 to 4, there's a video that you're going to want to watch. Okay. And then there's the lab itself. So I just wanted to show you that just so you can navigate through it. And then I'll show you the home page again. I'm hoping everybody has seen the home page. And one thing I forgot to do on the lab homepage, I did put the link to Discord. I still have to do that. The main course has the Discord link. Okay, and I also have links to the modules at the bottom. Okay. So let's go back.
Professor?
Yeah.
The picture that you have on the homepage, like I don't see it on my homepage. It just shows a lock.
Oh, it doesn't show up?
No, it doesn't show the picture that you have there.
Okay, let me go back.
Yeah, it was like that for me too.
This one at the top here?
Yeah, we don't see that.
Oh, wow, that's weird.
It's the same on both the homepage for the lab and for the lecture.
No, the lecture one's different. Can you see the one?
Yeah, I mean it shows like a lock on both of them.
So let me go to the lecture course. Oops, that's not the lecture course. This is the lecture course, so you don't see this?
Oh, okay, yeah. Yeah, this one is visible, but the other one is not.
Okay. All right, I'll have to look into that. Sorry about that. You can see everything else though, right?
Yeah.
Okay. Well, thanks for letting me know. I'll go. I wonder why it's not there. It's strange. If not, I'll contact the distance learning folks and maybe they can help me with that. Okay. I'll take care of that. But if you look at the modules page, it looks like this, right?
Mm-hmm.
Okay, good. I'll look into that to deal with the picture.
Yeah, it was just kind of boring seeing a lock there.
Okay, I'll talk to. Well, I'll look into it and see if I need to. I'll talk to the distance learning folks. Okay, so this is the assignment we're going to be doing. I mean, this is review for you. So you're going to be practicing on Sig Figs. I'll say a few things about Sig Figs in a minute. So you'll do some practice here. Some work with scientific notation. Right? When you write a number, technically when you write a number in scientific notation as a reminder, when you write a number in scientific notation like this, this number has to be less than 10 and bigger than 1. Okay, if you're doing it correctly, this number has to be less than 10 and bigger than 1. And then this has to be have the correct exponent. Now, I will. So now that I wrote that number down, I'm going to tell you about a pet peeve of mine. I'm going to tell you about a pet peeve of mine when people write lab reports. I actually take off points for that. Okay? Your computer can do superscripts. Your word processor can do word superscripts. Your calculator usually can't. WebAssign can't. But your computer can do that. So I expect you to write this in a formal way. Okay? So you'll see a comment saying format if you write something like this. Or it's even worse to me if you do this. That's even worse because what that was that 2.718 to the 8th. Okay, so don't do that. All right.
Would you be mad if we wrote it like an expanded? Or like if it's a big or small number, like a really big or small number?
Yeah, you know, if you do something like this, that's kind of irritating. Because then the reader has to count. I have to count the number of decimal places. Whereas it tells me right away. Okay.
Professor?
Yeah.
So I had a question, like, suppose the figures that we are calculating, they have 2 decimal places and we are doing subtraction. So then we will follow like the number of minimum decimal places, right? So
right.
If our answer should be to 2 decimal places and our answer is 0.002, then we cannot round the 0 to 1, right, in front of 2.
No, just 0. In other words, if you're doing
But then the calculation would end up being 0.
Yeah, if you're doing something like this, yeah, I would just say it's 0. Right? Okay. Because you only know you really this is going to be doubtful already, right?
Mm-hmm.
This is going to be meaningless after the doubtful digit. If this is doubtful, if I don't know this very well, then what's the purpose of me showing the next digit if I don't know this very well? So that's the rationale behind it. Okay. So, and you bring up a good point. So let me remind everybody about the rules for Sig Figs. So one, if you're adding or subtracting, you go by the least number of decimal places, right? So if you have something like this, let's do this one. Even though this one has 4 sig figs and this has 1 sig fig, your final answer is going to have 5 sig figs. You go by the least number of decimal places because you know this is to a 10th, you know that's to a 10th, and you know that's to a 10th. Okay? Same thing with subtraction. You go by the least number of decimal places. But when you multiply or divide, then you go by the least number of sig figs. So if you do a calculation like 2.375 times 1.22, your final result has to have no more sig figs than this bottom one. Because otherwise what you're saying is what you calculated, you trust what you calculated more than what you measured, which doesn't really make sense. And remember, the rules for sig figs are just a guide, right? They're guides. They're not really, there's no rigorous theoretical backing of these ideas. People develop them for the case where they don't want to use the theory of errors, theory of measurement. But you guys have done it. You guys did it in 205, the theory of errors. Okay? And so we're going to go beyond this in our class. And the theory of errors includes error propagation, right? So if we know error propagation, we can figure out whether or not I should keep the next digit or not, based on the uncertainty in each of the two values. So suppose I do a calculation that looks like this. According to the rules for sig figs, what is this answer? What do you think?
Is it 0?
It's 0. Because the first thing you want to do, you're going to subtract. And this goes to the question you were asking, Raptaj. This is 0. So the numerator is 0, okay? And so you're taking 0 divided by whatever that number is. You're going to get 0. So to the correct number of sig figs, this is 0. It doesn't say, it doesn't mean you have no error. It just means that the two values agree to 3 decimal places. That's how I interpret it. Okay, I interpret it as the two values agreeing to 3 decimal places. Make sense? Now, if this was a 3, oops. And I would subtract them, then I would have something non-zero at this decimal place. Why did I make that a 2?
Because 1 was odd.
Yeah, because we round to the nearest even, right? Because otherwise, if I write this and I'm told to round to this decimal place, then I round to the nearest even. Okay? And so one of the things I have been sloppy with here is not the units. I haven't written any units. So be careful too with the units. So on this worksheet, some of the quantities have units in them and some don't, so you have to be careful. You know, if you got to treat the units properly, so your final answer has to have the proper units. Okay? So when they grade this, if the units are wrong, or if the sig figs are wrong, or if the value is wrong, hopefully the value is not wrong, that's because you're doing it on your calculator. That's what I'm going to take off points for, okay? So be careful. So out of the first 14 items, You want to be careful with that. Now, the next exercise has to do with calculating averages. So let's say we calculated the average of 4 numbers. I have something made up. So,
Professor?
yeah.
In the last example, when you have 0.002, and you said like it was rounded because of the 5, wouldn't it be like a 3 if you were rounding? Or because like the 3 minus 1,
Oops.
like bring down a 2, and then you round to 5, I'm guessing, and it rounds to like,
Well, let's go.
5, I forgot. Never mind, my bad.
You got it? Okay.
Yeah.
Okay.
I also had a question.
Okay, go ahead.
We don't really count the 100% in Sig rules, right?
We don't count the rules for Sig Figs, you mean? You broke up, I'm sorry.
When we're
Chase.
multiplying by 100%.
Yeah, oh, I'm sorry. Yeah, 100% is a counting number. So counting numbers are considered to be exact. Okay, anything that's, when you write 100% or you say, it's a counting number, like I see 2 apples on a table, those are considered to be exact. Does that make sense? So the 100% has as many sig figs as you would like it to have.
Professor, when
Yeah.
we're doing the labs and we're like doing those big old like calculations, do you care about having units like in the big calculations or just like for the answer?
Just for the answer. I mean,
Oh, okay.
and I probably shouldn't say that. You should probably have the units in all of them, but as long as at least you have it in the answer. Okay. If I don't see any units anywhere, yeah, I'll probably dock you.
Because sometimes it takes up a lot of space.
Oh, I understand that. Some of them are quite complicated equations. So yeah, and I understand that. And then, but as long as there's something there that shows that you know there's units, that's fine. Is that okay?
Thanks.
Okay. So let's say I did a measurement of something multiple times. Let's say I only did it 4 times. And of course, if you add these up, they add up to 10. And according to the rules for Sig Figs, I get 10.00. And I want the average. According to the rules for Sig Figs, how many Sig Figs do I keep? Now, this is a counting number, so this is exact. How many Sig Figs do I keep now?
4.
4. Because I have 4 here. Now, in some classes, your professor might say, well, I only know these 2 values, so why should I add the next one? But then, what's the purpose of doing a repeated measurement? So there is an ambiguity here in terms of the number of Sig Figs I should keep. Some folks will say, just keep it here, and I'm saying, just follow the rules for Sig Figs. But there's a way to figure out whether you're correct or not. And that's by calculating the standard error. So how do we calculate the standard error? First, you got to calculate the standard deviation. So the standard deviation of some quantity that you've measured, and this is a review because I think you've seen this before, is 1 over n minus 1 times the sum of x sub I minus x average squared. So you first calculate the standard deviation, and then the uncertainty, or the standard error, in the value of x is the uncertainty divided by the square root of the number of measurements. Okay. On the labs, I do check if you're doing this correctly. I mean, one of the problems with doing this calculation is if you write this out, if you write out every term, it'd be kind of cumbersome. If you just write the first couple terms on your lab, that's fine. And you do dot, dot, dot to show and say, this is how the rest of them are done. That's fine. Okay. All right. Now, suppose we measure quantity X, Y, and Z. And we get the average of X and its uncertainty, the average of Y and its uncertainty, and the average of Z and the uncertainty. And we're going to use this in some subsequent calculation. Maybe let's say volume or whatever it is. I'm going to use these measured quantities to calculate something from my lab, whether it's a volume or some kind of density or whatever it is. How do I know what my error is in my final result? Okay. In other words, suppose I have to calculate something that's a function of X, Y, and Z. How do I know what delta A is? And so the error propagation is what we do. Now, those of you who had me for Physics A, I gave you the equation. Now that you've had Calc 2 and Calc 1, I'm not going to give you the equation anymore because you can figure it out, right? So if I want to know the uncertainty in A, and I've measured these quantity, and A depends on these variables, then delta A is the square root of the derivative of A with respect to X, keeping Y and Z constant. Have you seen this symbol before? This is a symbol for partial derivatives. Okay? And then we square it and then multiply by delta X. And we do this for every single variable in this expression. So the second page of the exercise has you going through and doing these calculations for our various functions. Some of them are ones we use commonly. Okay, so that's what the second page will be for in the document. Just reminding you how to do air propagation. And we don't do a lot of labs where we do air propagation this semester. Okay? We do a lab called Ohm's Law, and it's a lab where you make measurements, but we hardly do any air propagation in that lab. There's probably only three labs this semester where you have to deal with it. But I want to remind you of this stuff, so that's why we're doing this exercise. Okay? Now, so and this should all be familiar to you. And this question was brought up. If you measure something, how should we report it? You should always report it with the average value and the uncertainty. Okay, always report the average value along with the uncertainty. You should always write something like 3.58 plus or minus. Don't do this, okay? This is not good. This implies that this doesn't have units. This thing has units because it reflects the uncertainty in what you measured. So it has to have the same unit as what you measured. People forget that. And then don't do something like this either.
Would you dock points if we didn't have it in parentheses?
Well, if you wrote it this way, you'd have to write cm here. Right? But if you don't, if you leave it like this, usually if you do it repeatedly, yeah, I'll take off points.
Because usually like last semester we had like a blank, and then oh wait, no, I don't know how I'm explaining this. But like, what if I put like the centimeters not behind the 3.58, but behind the 0.08? I just didn't do the parentheses like your first.
Yeah, I mean this is better.
Mm-hmm.
Okay, but not having one, if you repeatedly just write it so that you only have units on one of them, I don't know if you understand that both of them have the same units.
Okay.
Okay. And in the real world, that's how it is. Okay, I'm trying to do things the way it's done in the real world. Suppose I do this. Don't write it like that. It's kind of annoying. Okay, write it in scientific notation. 1, 2, 3, 4, 5, 6. That's how I would write it. Okay, I would have the same exponent on both values. I know this is not correct scientific notation, but again, for the person trying to read it, it's convenient. The goal is to make things easy for the reader to read. Oh yeah, by the way, with lab reports, you're not writing to yourself. When a lot of students, when they write a lab report, they write to themselves and not to somebody else. They're not thinking about what somebody else is, how somebody else is going to perceive what you wrote. Most students will perceive, and I do it too, as a faculty member sometimes. I write it as how I would perceive it and not as how somebody else would perceive it. Okay? So you're trying to communicate technical information, so make sure you understand that you're not writing to yourself. You're not taking notes. You want to make somebody else understand what you wrote. Okay? That's important, especially those of you who end up becoming engineers and have to write reports all the time. Okay? All right. What's the difference between precision and accuracy?
Accuracy is how close the value is to the true value, and precision is the repeatability, how close the measurements are to each other.
So precision reflects consistency, right? Reproducibility, consistency. Whereas, yeah, accuracy, it reflects how close you are to the true value. Okay, so what are and this is all review, what are the different types of errors that occur in an experiment?
Random.
Systematic.
So there's random, systematic. What's the third one?
Blunder.
A blunder, yeah. This one means you screwed up. Okay? So you're doing these labs at home. Your goal is to submit a lab report without a blunder. You don't say, oh, there might be a mistake in my calculation. Check it. And if you're not sure, ask somebody. Don't just turn in something with 100% error. It tells me you don't care. Of course, then I'm not going to care about the grade either, right? So don't turn something in with a blunder. Okay. A human error is ambiguous. Do not use the term human error. If I see the term human error, I automatically take off points. Okay, because it's ambiguous. It doesn't, because it could either mean you screwed up, which you're not supposed to, or it means you're misinterpreting what a random error is. Okay, so I don't use that term. Now, I guess the question is, how do you know whether or not in an experiment this or this dominates? How do you know whether a random error or systematic error dominates in an experiment, the experiments that we do? Now, we have to remember that when we quote a value, well, let me see the comment. Systematic error occurs. The thing about systematic, let me go to that comment. Systematic errors happens to everyone. They do, but if you modify your experiment, you can get rid of them. Random errors, you can't.
It's just, my bad. Sorry.
I'm sorry?
I was gonna say the systematic error, like, will shift the data one way, and then the error is kind of unavoidable because measuring device.
You're right. The systematic error will shift the your data one way. This can shift it either way. This will do it consistently one way. This will be either way. Okay. Suppose I do a measurement of the density of aluminum. So I get the density of aluminum to be 2.68 plus or minus 0.01. Let me make it more. Let me do it like this. So let's say I did this measurement. And this uncertainty that I'm accounting for only takes into account random errors. Right? In our course, in the courses you take at Sierra College, this number is really going to be reflective of random errors. In general, there's one or two cases where that's not true, but for most of the labs that you do, this only takes into account random errors. Okay, if the density of aluminum, and I've got to be careful, is 2.70, the range of values that your measurement includes does not include 2.70. And since this accounts only for random errors, that suggests, I'm saying it suggests, I'm not saying it actually is, that you have a systematic error. Okay? You can only say it suggests. You can't say anything for sure. Unless you can account for how big these errors are.
Professor?
Yeah.
So like if when we do not do repeated measurements, like we have done only one measurement, then the uncertainty is of the instrument itself. So would that also denote systematic error?
Yeah, and we got to be careful because a lot of times if you're using the quoted error from the instrument, from the manufacturer, they actually take into account systematic errors. Now, if you're using a scale, for example, and that's what you ask is a hard question. If you're using a scale and you have an error, it could be you didn't calibrate your scale. In other words, you didn't take a standard, put it on the scale, and see what, several standards, see what they read. If you didn't calibrate it, that would introduce a systematic error. So, yeah, and I would always say the word suggests and not say definite. Right? It's hard to say anything definite.
But it definitely wouldn't be a random error, right?
No, especially if you measured once.
Yeah, okay.
Yeah. Other questions? Okay, so so there's the third page, the last part of the assignment has you answer some questions regarding this. Okay, any other questions?
I have a question.
Go ahead.
So whenever we are given a measurement with its uncertainty and nothing is told, then should we assume that several measurements have been done to get that uncertainty?
Yeah, that's a good question. I'm trying to think of where we would encounter that. Yeah, I guess assume that several measurements were done. We can assume that.
Okay.
Other questions? No other questions? Okay, so this is due in a week. Okay, and what you're going to do is you're going to upload, you'll upload this document onto Canvas. Okay, you just find this assignment on Canvas in our module and just upload the file. And then I will use the speed grader to grade the assignment, which is, it takes much longer for me to grade assignments when they're online. So some weeks you might have to be patient. I'll try to grade this one as soon as I can. I do want to say something about, since it's already almost 9:15, I'm not going to be able to do relativity here. I'll just continue in lecture with what I was with the relativity lecture. I do want to say that if you go on Canvas and you look at the video assignments where you have to create a video, I have created a rubric within Canvas, and so that's how I'm going to grade it. So you might want to take a look at the rubrics that I have for the video assignments, and so so that you get an idea of what I'm looking for in the videos. Okay. Basically, in the videos, I'm trying to get you to demonstrate something and show me that you understand how something works. Okay. So if you look at the rubric, then you know how I'm going to grade it. How I'm going to grade the video assignment. Typically, based on my experience from the last semester, the grades on the videos, if you do everything, tend to be better than the grades on the written reports. Okay. So for example, the multimeter quiz that we do, if you do everything correctly, which is not that hard, and you upload it to YouTube, you do have an option instead of YouTube to use Canvas Studio. You have an option to create the video in Canvas Studio. Then that's, I just don't want to upload a file because it takes forever. I had some files that were 3 gigabytes last semester. That takes forever to upload. Okay. Like this lecture right now, when I upload it to YouTube, this lecture is going to be about 10 gigabytes. It takes hours to get to YouTube, and then YouTube has to process it. So I don't want to deal with that. Okay. So you can use Canvas Studio. If you don't want to use YouTube, use Canvas Studio. Okay. But anyway, the video is just to convey, the idea is to convey the fact that you understand how to use a piece of equipment, or you understand the experiment. Okay. That's really all there is to the videos. I do recommend that you do the experiment once or twice before you create the video. I had some videos last semester where the student was recording the video as they were doing the experiment, and they were like 40-minute long videos. And in this one particular case, nothing worked for the student. So that student got a bad grade. Okay, so you want to make everything work first and then create the video. Because if you do it on the fly, it ain't going to work, and what you're going to be turning in is not something you're going to be proud of. Okay. Now, on the other hand, I had some people who are experts at making videos. They were unbelievable. I was shocked at how good they were. So,
would you give them recommendation?
I'm sorry?
Would you give them recommendation?
Oh yeah, they were awesome. Those videos were awesome. I mean, it was amazing. Some people they did their lab in 3 minutes. Right, the video was 3 minutes long, as opposed to some being 20 minutes. So, and everything was there. Everything you need to know was there. It was awesome. So, anyway, yeah, I guess I'm not going to start anything new. The other thing, you know, we did the motor lab. The one drawback of doing the motor lab online is that you don't have the testing equipment. Well, most of you don't have the testing equipment that we have in the lab. And so it's a little bit harder for you to get the motor running at a lower voltage. So my standards are a little bit more lax online. So to get an A on the motor lab, you just have to have a motor that runs on 3 volts, whereas we're on campus, it's 2 volts. And because we have the nice power supplies, we have gotten students run those motors at 1 volt. It's amazing how you can get those motors to run at 1 volt, but I mean, some people really go to town on that lab. But since it's online, 3 volts is fine. So, and most people should be able to do it. Okay. And you have to communicate with me if you're having trouble, or you have to go onto Discord or discussion board if you're having trouble. Tyler has created some videos for some of the labs because it is going to be hard for me to demonstrate some of the labs in my house. But I'll do the best I can. And then Tyler's been on campus to actually make some of the videos. Okay. And I've included some links. So I'm going to stop here. I'm not going to, it's too late to do my presentation in relativity for now. I'll stop here and then we'll continue our discussion on relativity in class today. Okay? No more questions? All right. So we'll see you later then. Okay? And you know,
Thank you.
yeah, let's try to keep our chat to stuff in the class and not other stuff. All right. We'll see you later.